Hi everyone, we are tubtimgrob group. In this video, we will talk about technical debt and who define it.
Ward Cunningham or Howard G. Cunningham is an American computer programmer who developed the first wiki and was a co-author of the Manifesto for Agile Software Development. He was born in Michigan City, Indiana on May 26, 1949. Cunningham is interested in design patterns, extreme programming, exchanging ideas, tracking the number and location of wiki page edits as a psychological experiment. And he once said that he has always been interested in how practice spreads in engineering communities too. He worked for Microsoft Corporation for 2 years, but since 2005, he is currently the director of Computer Community Development at the Eclipse Foundation.
For the significant award, he got the Dobb Excellence in Programming Award in 2012. It is an annual prize given to individuals who made significant contributions to the advancement of software development.
What is the technical debt? You may be wondering what technical debt is. It is hard to understand. I will tell you that is very simple to understand. It really happens when a development team make a decision to rush to deliver a piece of functionalities. In other words, the team emphasizes the speed over the performance. Technical debt can catch everything, including bugs to missing documentation. Agile is dependent on reducing scope of a release to ensure quality of work. If the team did not reduce scope of release, so technical debt can passively create it. The way to avoid this technical debt is to making an awareness to developer, following the code practice, and using issue trackers. How many types of technical debt? There are 3 main types of technical debt, which consist of first, deliberate technical debt. In some cases, developers need to rush to deliver the product, thus it can cause technical debt. Second, accidental technical debt. Developers trying to simplify the software for the future development, but sometimes things can go wrong. As you may know, the requirement can change later on. Third, bit lot technical debt. It happens when some developers do not understand the design of system. That leads to complexity of the system. So, how does technical debt happen? The technical debt can be caused by time pressure, overly complex technical design, poor alignment to standard, lack of skills, suboptimal code, delay refactoring, and the last one is insufficient testing. So, when technical debt happens, what will happen? The technical debt can lead to poorly designed code, volatile performance, drained productivity, test strain. The way to solve this problem are separated by type of technical debt. The first way is to use the backlog to tracking the technical debt. Therefore, the release may be postponed. The second way is to refactor a system. The third way is to trying to avoid bit lot technical debt at all costs. So what is the role of technical debt in software development? The technical debt is related to the Agile and Scrum.
For the benefits of technical debt, as you know, it is debt, but it also has benefit by the way. In case of the software that the code is too complex to maintain, technical debt can get you a solution much more faster, and that solution can get you the advantage of the time to market, which lead you to the customers faster than competitors. In the past of the expense, in short terms, technical debt can saving the cost of the software update, but actually not safe. It just delays the implementation phase of current version of software before the better versions come up. But anyway, the major of that is downside. After a representation as a technical debt, eventually it must be repaid. So there are two main downsides of technical debt. First one, reduce forward motion. Instead of developing the product, the development team has to struggling with the quick and dirty code. The second is poorly designed code. This can make the project complete in time, but it will make the other programmer difficult to clean it. The last one, bad quality. As the technical debt drain out the productivity, it makes the outputs not effective, and finally, the product is not going to answer the requirements. And next is the impact on the SCE community. Since the technical debt became a metaphor that cannot avoid from the development and difficult to eliminate completely. Many practitioners from the software development communities have suggested several ways to reduce the technical debt, whether it is a code review, test-driven development, eventually design, and others. These practices are mainly to identify, classify, and reduce the technical debts, but not enough to reduce all of them. So in role of developer, we should minimize the technical debts as much as possible.
For the development of the topic, Cunningham, who is one of the authors of the Agile Manifesto, once says that some problems with the code are like financial debt. It is okay to borrow against the future as long as you pay it off. Initially, what metaphor which he called technical debt. This metaphor is gained a momentum since he first used it. While people are still discussing the exact definition of the technical debt, the core concept identifies a serious problem that many software teams are struggling to manage. Watt initially used the word technical debt when he was developing a finance application in Smalltalk. He presented a financial analogy to justify the refactoring they were doing to his boss. He explained to his boss that
if we fail to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan.
Later, at the OOPSLA Conference in 1992, Watt provided additional details. He used the metaphor technical debt to explain to non-technical stakeholders as YCAS, why resource needed to be budgeted for refactoring. Watt said that shipping first-time codes is like going to desk. A little desk speed development so long as it is paid back properly with refactoring. After that, it would become the subject of countless academic study, debates, and panel discussions. The next year, Cunningham described how he initially came up. Watt elaborated further in the highly viewed videos.
With borrowed money, you can do something sooner than you might otherwise, but then until you pay back that money, you'll be paying interest. I thought borrowing money was a good idea. I thought that rushing software out the door to get some experience with it was a good idea, but that of course you would eventually go back, and as you learn things about that software, you would repay that loan by refactoring the program to reflect your experience as you acquired it.
Watt further said in a later interview. Say that the code is of high quality when productivity remains high in the presence of change in the team and goals. I would say that the debt is localized within a team, its goals, and the cost offered by a team to meet those goals. In reviewing this paper, Watt added, when I talk about repaying debt, I am assuming that the software owner decides to keep the value invested in the software for future developments. This isn't always the case, however. If a liquidity event is on the horizon, it might make sense to put debt
into software. This is where business strategy meets engineering strategy. We could summarize the metaphor as follows. A development team incurs technical debt when taking shortcuts and delivering code that is not quite right for the programming task of moment. Did that decrease productivity? This loss of productivity is the interest of the technical debt.